All right, written problem 6, solutions for math 112. What we're doing in this problem is essentially we're working in both directions. So what I mean by that is I'm going to start you out with an equation here and ask you to come up with the graph. And then once you have that graph, I'm going to have you take a look at that graph and come up with an equation that represents that graph. So we'll kind of go in a big circle here. So our function f of x is negative 2 times the sine of 1/2 x plus pi over 4 plus 1. Or if you want to think about it as a times the sine of bx plus c plus d, playing the role of a is a negative 2 for this negative 2. Playing the role of b is a 1/2, the coefficient on this x. Playing the role of the c is the pi over 4, what we're adding to the term with the x in it inside the parentheses. And playing the role of the d is a positive 1, what we're adding to the output of this sine function. And with these four values, we can figure out the amplitude, the midline, the period, and the phase shift. The amplitude is always just the absolute value of a. So since a is negative 2, it's the absolute value of negative 2, which is just equal to 2. The midline is always just d, or technically speaking, the equation of the line is y equals d. So technically y equals 1, although you could just say 1 and we're good. The period is always 2 pi divided by the absolute value, technically speaking, of b, although I've told you b will always be positive numbers, so you can just do 2 pi over b if you want. Since b is 1/2, it's 2 pi divided by 1/2, which, if you think about this, 2 pi is 2 pi over 1 and multiply by the reciprocal of the denominator. You can calculate that the period is equal to 4 pi. And then finally, the phase shift, that's always given by the negative of c divided by b. So in this case, negative pi over 4 for the negative c divided by 1/2 for the b. Maybe this time I'll show a little bit more work to divide these two fractions. You can multiply by the reciprocal of the denominator. So take this 1/2 and flip it upside down. And now I can either multiply straight across or cancel this 2 with one of these 2's. Either way, what you'll get is negative pi over 2. Now that I have amplitude, midline, period, and phase shift, I can come up with the graph. So I'll start with my scaled x and y axes. And I think it's easiest to first draw your midline. So my midline is given by the equation y equals 1. So this dotted line with the height of 1 will represent the middle, vertically speaking, of my graph. And then from there, since the amplitude is 2, I want to go up by 2 and down by 2 to represent the maximum and the minimum y values of this graph. So 2 less than positive 1 is this negative 1, and 2 more than positive 1 is positive 3 here. These are the bounds that will help me draw my graph in the vertical direction. Now maybe I can worry about the horizontal direction. Since my phase shift is negative pi over 2, I want to start one full revolution of my graph over here at negative pi over 2. And since the period is 4 pi, it has to travel a distance of 4 pi in the horizontal direction to make one full revolution. So if it started at 0, it would take all the way till I got to 4 pi over here to do one full revolution. But we're not, loosely speaking, starting at 0. We're starting at negative pi over 2. So it'll end over here at 3.5 pi. From negative pi over 2 to 7 pi over 2, I travel a distance of 8 pi over 2, in other words, 4 pi. None of these lines are actually part of the graph, but with them, I think we can pretty easily sketch one full revolution of our graph. Note that since we're modeling the sine function, we want to start on the midline. So here's a point right here that'll actually be on my graph. Since I start on the midline, I'm also going to end on the midline, and halfway in between these 2 points, I'll be on the midline. Now all I have to do is figure out, should I start by going up or should I start by going down? Well, the sine graph normally starts out by going up, but because this is negative, my orientation is flipped. So what that means is I want to achieve a minimum, not a maximum, halfway in between these first 2 points. So over here at pi over 2, my height will be down here at negative 1. And then over here at 5 pi over 2, 2.5 pi, I'll achieve a maximum, so my height should be equal to 3. With all these dots, it's easy enough to draw one full revolution, which is sufficient for your answer. However, this graph continues infinitely in both directions, so I typically draw at least a little bit more and draw some arrows to show the reader what's going on. Now we move down to question 2, where it says find an equation of a transformed trig functions whose phase shift is negative 3 pi over 2 and that has a graph identical to what we see here. So negative 3 pi over 2 is talking about this point. I want to think about what if my graph started, loosely speaking, at an x value of negative 3 pi over 2. Well, I might have to draw a little bit more of my blue curve here to really see what's going on. Remember, the period of this blue curve is 4 pi, so it takes 4 pi to do one full revolution. So half of that, 2 pi, I should return to the midline. So what I'm saying is 2 pi to the left of this point, over here at negative 5 pi over 2, I should be back on the midline. And if I'm back on the midline here, halfway in between here and here, namely at negative 3 pi over 2, I should be up at a maximum. So if I add on the part in red to my graph in blue, it might be a little bit easier for me to come up with the equation of a transformed trig function whose phase shift is negative 3 pi over 2. Starting over here at negative 3 pi over 2, a distance of 4 pi is what it takes to do one full revolution. So I can kind of think about one full revolution as being bounded by these two red vertical lines. And then if you stare at this one full revolution, you notice that since it starts out up here at a maximum, I should model it with the cosine graph. My period is still 4 pi, my amplitude is still 2, my midline is still at 1, and now my phase shift is negative 3 pi over 2. Well, let's see, let's go in order. Since the amplitude is still 2, I know that the absolute value of A is equal to 2, so A is either positive 2 or negative 2. I don't know which just yet. The midline is 1 for the graph that I see here, so that tells me that my value of D is equal to 1. The period is still 4 pi, so that tells me that my value of B is still equal to 1/2. But now my phase shift is negative 3 pi over 2. So that tells me that negative C over B is negative 3 pi over 2. And since B is 1/2, I can plug that in and get an equation that only has C's and numbers in it to solve for what C must be equal to. One way you can do that is simplify the right-hand side of the equation. If I divide by 1/2, I can think about multiplying by the reciprocal of the denominator to get a negative 2c over on this side of the equation. And then instead of dividing both sides of the equation by negative 2, since that'll introduce fractions inside fractions, what I'll do is I'll multiply both sides by negative 1/2. That'll get rid of this negative 2. The negatives cancel on this side, and I'm left with 3 pi over 4 that's equal to c. So I know B, C, and D, and I almost know A. If the absolute value of A is equal to 2, I just have to figure out if A is positive 2 or if A is negative 2. Since I'm starting up here at a maximum value, I know that the normal orientation for cosine is to start up at a maximum. So since I'm using the normal orientation, my value of A is equal to 2. So I can write my answer by following this format except using the cosine function. I have 2 times the cosine of bx plus c, so 1/2 x plus 3 pi over 4, plus d, which is equal to 1. This equation has a graph identical to what we originally drew in blue up here. However, it has a phase shift of negative 3 pi over 2, as we were instructed to use for part 2. So that's the answer, and that's the end of this video.